Okay, now you already know some basic concepts about the ZW3D assembly design. In the next few chapters, we are going to learn assembly functionalities based on the assembly workflow. Alright, first let's talk about creating an assembly. In this chapter, we are going to learn how to create assembly, how to insert components, and place them correctly with various constraints. Okay, in the first place, we need to create new assembly. It's easy. Just select the main type and subtype. Then select the template and input its name and description. Then you are ready to go. After that, we can insert existing components or new part inside the assembly. There are several ways to do that. For example, standard insert. We can insert one component at one time. As for multi-insert, as the name suggests, use it we can insert multi-components at one time. New to insert means creating an empty component or sub-assembly in the current assembly level. And for the next one, include unplaced components. It means we can insert a component node, but without loading its geometry. It's useful for some special cases where you need to include the component in the BOM table, but you don't really need its 3D model. And the last one is insert smart fastener, which we will cover it later on. Okay, now let's move over to ZW3D to show you more details. Okay, now we are in ZW3D interface. So first, let's create an assembly. Click New. And for type and subtype, we can keep it assembly and standard. And for template, now we only have the default template. And later on, I will show you how to create your own assembly template. Okay, and for the name, you can give it a name you like. ASM001. Okay. And for description, you can make it as you like. For example, here, for ejector. Okay, we can click OK to continue. Okay, now we are in assembly environment. And as I said before, in the top is the title. And the lower area is the ribbon. All the commands are in the ribbon area. Okay, and the right is the assembly manager. And the middle is the graphic area. And the right is the file browser and also the standard parts library. Here you can see all the standard parts library here. Okay, and in the bottom right is the output window, and in the bottom left is the command line. It will guide you what to do next. Okay, this is the interface introduction. And next I'll show you how to insert components. As you can see, we have 5 insert commands here. So let's see it one by one. First is standard insert, which means we can insert a component at one time. Okay, we insert one base plate, and here you can see we have many types of placement method. And the first one is point, which means we can insert once. Okay, let's insert again. And here you can see the default one, which is also the second one, is points, which means you can insert multi times for one component. And actually we have some other like auto hole match, layout, active frame, and etc. You can try it by yourself. Okay, now we can click OK to get the result. Okay, so this is the standard insert. Okay, now we can delete the useless components copies. Okay, delete. Okay, now let's continue to introduce the next one. New to insert. This one means you can create a new component inside the assembly. Here we can give it a name, like part 2. Okay. Okay, now you can see it will activate the new component. For example, we can create a little block here. Then we can go back to the assembly level, region it. Okay, now we have created a new component inside the current assembly level. Okay. And the next one is multi-insert. For this one, we can insert multi-component at once. Okay. For example, here we insert 1, 2, 3, 4. Okay, and plus the first one is 5 components. Okay, and here we can set it as scatter, which means it will scatter with a distance. Okay, click OK to get the results. Okay, this is about multi-insert. And the next one is include unplaced component. This one means you can insert a component node without loading its geometry. For example, we insert this one, but you can see after we click OK, there's no geometry in the graphic area. And you can see the icon in front of the component is different with others. Okay, you can see only a node without geometry. But it will include in the 3D BOM. Here you can see. So it's useful for some special cases when you need to include the component in the BOM table, but you don't really need its 3D model. Okay. And also, if you want to load the 3D model again, you can just right-click and load component. Okay, now you can see it's in the graphic area. Okay. And the last one is insert smart fasteners. For this one, we will cover later. Okay, next I'll show you how to create our own assembly template. Okay, first we'll create assembly. Like we name it ASSM template like ZW. Okay. And now we can set some attribute for it. Here, tools, property. For example, we can set the number like ZW12345 6. We have designer and supplier ZWSOFT. We can other description keywords, you can edit as you like. Okay, and also we can set the material for it. Okay, now we can apply and click OK. Okay, now we can save it to the destination path, which is in the installation path. For me, it's in my D disk, ZW3D, and the language, I'm using the English language, ENUS. Resource. Okay, we can save it here. Remember this path, please. Okay. Okay, now it's done. We can close it. And next, when we create a new assembly, you can see we can choose our own template. Okay. Now you can see all the attributes are in it. Okay. Okay, now we have inserted some components in. Next, we need to place the component properly. In some cases, we can fix the component in the current position directly. We can find the fix command in ribbon or right-click menu. The component cannot be moved or add constraints to after fixing it. And of course, you can get it back to float by the same way. By the way, for the first inserted component, it's recommended to use frame constraints to make it well-defined instead of fixing it. Just now, I have shown you how to fix the component very quickly. But for most cases, we need to add constraints to make the component well-defined. So next, I will show you how to add constraints to a component. The normal workflow is simple. You just need to select two geometries and then define the constraints you want. then click OK to finish. That's easy to understand, right? Besides that, there are more tips or skills you need to know when adding constraints. First one is manipulate handle. Use it, you are able to adjust the component position for better and more precise results. And another thing about the handle is it will show the freedom degree of the component by different color. And another thing is the minibar. You can turn it on to get a quicker way to add multi-constraints. Lastly, you can control the display mode of irrelevant components as shade, hidden, wireframe, and transparent. Alright, and when adding the constraints, time to time we need to show the component's datum plan. Here I get you two ways to do it. First way is execute the command in the right-click menu. And the next way is unblank the component datum for all components directly. Okay, now you already know how to add the constraints and all the skills. Next, let's see some common constraints. Here you can see the 11 common constraints in ZW3D. The first one is coincident. Use it, we can make two geometry coincident. The geometry can be face, datum, edge, and also point. It's also one of the most commonly used constraints. The second one is tangent. Use it to make a cylindrical face, conic face, or spherical face tangent to another face. And the next one is concentric. Use it to make two geometries share the same center line. And the next one is parallel. Use it to make two geometries parallel. And next one is perpendicular. Use it to align two geometries at 90 degrees. And the next one is angular. Use it to align two geometries at a certain angle. And the next one is lock. You can use it to keep the relative position and orientation of two selected components. And the next one is distance. Use it to position two geometries by a certain distance. And next one is middle. Use it to keep the base entities in the middle of the center entities. And the next one is symmetry. Use it to make two entities to be symmetrical about datum plan or planar face. And the last one is frame. We can use it to make two coordinate system coincident. Okay, now let's move over to ZW3D to show you more details. Okay, next I'll show you how to add common constraints. Okay, first we need to place one component in. Base plate, add it here. And for some cases, we can fix the component in the current position. For example, we can just right click and fix it. Now you cannot move it, right? But for most cases, we need to add the constraints to make it well defined. Okay, so we can right click again and we make it float. Then it's movable. Okay, next I'll add some constraints to it. For the first inserted component, it's recommended to use the frame constraint. Okay, before that, we need to do more little step, which just show the external datums of the component. There are two ways. The first way is you just right click on it and you unblank external datum. Then you can see it will show. Okay. And the next way is you can right click on the assembly tree and then show history features. Then you can see the history of this component will be displayed here. Then you can select it for the constraints. Okay. So we will add the frame constraints. Okay, common constraints command here. Click on it. And the last one, frame constraints. We can use it to make two coordinate system coincident. For example, the coordinate system of the component and the current assembly coordinate system. Okay. Now you can see it's well defined. Okay. We didn't show it. And next, I'll show you more common constraints. So first, we can insert more component in. Multi-insert. Slider base, slider spindle. Okay. And we can make it scatter. Okay. Now we add more components in. So next, I'll show you how to make this assembly. Okay. First, we add the constraints for this component with the slider base. Right-click, common constraint. So first, we make a coincident. The bottom face and the top face of the base plate to be coincident. Okay. So here you can see, actually we have a mini bar here. You can make it not pop up by uncheck this option. But for me, I used to check it, so you can add the constraints more quickly. Okay, and we'll add more. This hole and this hole. Okay, we click OK to make a concentric. Okay, next I'll make a parallel. We make this face and this face to be parallel, then it will be well defined. Okay, first the face. And here please note that there is a manipulate handle here. And you can see this handle will show the freedom degree of all directions. Okay, you can see if the direction is well defined, it will display it in white color. You can see. So for this component, actually we only have one freedom degree here. Okay, so after we add more constraints, which is parallel here, it will be well defined. Okay. Then we add more constraints. We make this face and this face to be coincident. And then we add more. And here you can see, actually you can set the display mode for the unrelated components here. You can see we can set a wireframe or some other display mode. Okay. And continue. And we add more for this spindle. Okay. And this one. Concentric. And we'll add more. Actually, when sometimes it's difficult to find some geometries, you can just drag it so you can see it more clearly. Okay. Add common constraints. This face and this face to be coincident. Okay. Okay, now let's continue. This face and this face. Okay. And we'll add this face and this face to be coincident. Okay, finally we add a tangent constraints. Tangent. This one and this one. Okay, we change the direction. Okay, now it's done. Okay, we can drag it to verify if everything is working fine. Okay, now it's good. Okay. Next, we can make a mirror for this component. Okay, now we are done. And besides those constraints I have shown you, actually we have more common constraints here. It's easy to understand, so you can check it by yourself, like the perpendicular, angular, log, distance, middle symmetry is easy to understand, so I will not show you here. Okay. Just now we have learned common constraints. And ZW3D also provides 8 types of mechanical constraints. Now let's see it one by one. The first one is gear. Use it to force two components to rotate relative to each other about the selected axis. The second one is path. Use it to force the selected points of the component to the path. The next one is linear couple. Use it to establish relations between the translation of one component and another. And next one is rack and pinion, which means linear transition of one component, which is the rack, causes turnover of another component, which is gear, and vice versa. And the next one is screw. Use screw, we can add relations for the rotate of one component and the linear transition of another component. And next one is slot. Use it to confine bolt movement to slot hole. Next one is cam. Use it to force a cylinder, datum, or point to coincide with or tangent to a series of tangent surfaces. And the last one is universal joint, which means the rotation of one component about its own axis is driven by the rotation of another component about its axis. And there is another thing you can do to add relations among several components, which is pulley, which can be used to design belt, chains, and etc. Now let's move over to ZW3D to show you the mechanical constraints and the pulley feature. Okay, now let me show you the first one, gear constraint. It's easy to understand. We can just click mechanical constraints and select the gear constraints. As for the input, we can it's recommended to select the pitch circles of the two gears. Okay, so first the bigger one, and then the smaller one. Okay, now we can make the gear ratio, which is also the transmission ratio. We can use the teeth to calculate the ratio automatically, or we can just input the ratio by yourself. So for this one, we can input the teeth. Okay, for the first one, the teeth is 18, and the second one, which is also the smaller one, is 12. Okay, now we can click OK to get the result. Now we can actually rotate it a little bit to verify. Okay, now you can see it's very good. Okay, this is for the gear constraints. Okay, the next one is path. Okay, with it we can bind the points of the component to another path. Okay, for example, we can bind this center of the ball to the path of this component. Okay, so let's see how to do it. Mechanical constraints. Okay, we use a second one, and first we need to define the point. Okay, we can change it to wireframe and select the point here. Okay, and the path, which is the center line of the other component. Okay. Now actually we have more options. The first one is the path constraints. We can set the start point of the first component. For example, we can make the distance, or we can make the percentage. For example, we can make like 50. Okay. Now we can click OK to get a result. Okay. Now actually you can see this ball is in the middle area of this path. Okay. And we can verify it. You can see it's fixed. Okay. So if you'd like to make it run along the path, you can redefine it. Sorry, not this one. Redefine it and make it just free. Okay. Now you can say it's available to move. Okay. And actually there are more options like the pitch and the yaw control. You can see we can change it to X, Y, or Z to make the orientation of the ball. Okay. Okay, this is the final result. Okay, this is about the path constraint. And the next one is a linear couple. With it, we can establish relations between the translation of one component and another. Okay, so for example, for this case, we can make it to see the result. Mechanical constraint, linear couple, and now we define the first component and the move direction. Okay, this one. And the second component, and also the direction to move. Okay. Now we need to set the ratio, which means when the first component move, how much will the second component move along it? Okay, so we can make it like 2 here. Click OK. Now we can move it to verify. You can see the green component is moving slower than the yellow component, right? Okay, and also we can make it like in the other direction. You can flip it. Now you can see it will move oppositely. Okay, this is about the linear couple constraint. And the next one is a rack and pinion. We use another case for this one. Okay. So to make the rack and pinion constraint, actually there are some preconditions. The first precondition is the module of the rack and pinion is the same, must be the same. And the second condition is the pressure angle of the rack and pinion must be the same. Okay. With these preconditions, we can do the rack and pinion constraint. Okay. So, and also, we need to use the pitch circle of the rack and the pinion, of which I already made it before. Okay, now we can make it mechanical constraint, rack and pinion. So first, we select the rack and also the pinion. And here we need to define the value of the distance divided by a revolution. Okay. So this value equals to the pitch distance multiplied by the teeth number of the rack. Okay, which is Z. So actually I already calculate for this case. Okay, so we can just use it. This one, you can see this is the teeth number and this is the pitch. Okay, now we can click OK to get the result. Okay, now we get the result and then we unsuppress it. Now we can verify the result. This is the final result. Okay, whether you drag the rack or the pinion, the other one will rotate or linear move accordingly. Okay, this is about the rack and the pinion. Okay, next one is screw. For screw, which means the rotate of one component will cause the linear transition of another. So in this case, when we rotate the worm, it will cause the linear transition of the spanner lip. Okay, so before we made this constraint, we need to do one more step. We need to make a assistance line for the spanner, and the assistance line must be coincident with the center line of the worm. Okay, since I already made it, we can continue. Okay, mechanical constraint, screw. So first we select the screw entity. We can select the cylindrical face of the worm. Okay, here we have a little tip. Right click, pick from list. Okay, this is the cylinder face of the worm. And the linear entity here. Okay. For the ratio, it means when the screw turns around, how long will be the linear movement be. So you can calculate by yourself. So for this case, I already calculated as this value. Okay. And you can choose same facing or opposite. Okay. Click OK to get the result. Here you can verify it a little bit. You can rotate this one. Now you can see the spanner lip will move. Okay. Okay, next one is slot constraint. We use another case. Okay, you can see for this case, before we add the constraint, the machine cannot be moving very well. Okay, right? So we can try to add a slot constraint. Mechanical constraint. Okay, for the first entity is the bolt. Okay, and for the slot faces, we can choose one of them, and the other will be selected automatically. Okay, now we can click OK to get a result. Okay, now we can try. Now you can see it's working well. Okay, next one is cam constraint. Okay, we use another case. Okay, for this case, before the constraint is added, we can verify it. You can see nothing happened to the cylinder. Okay, so we can add it right now. Mechanical and cam. The first entity, we can choose this cylindrical face. And for the cam faces, we can select a series of the tangent surfaces. We just choose one of them. Okay. Now we can click OK to get the result. And then we can verify it. Now you can see it's working well. Okay, the last one is universal joint. We use another case, this one. As you can see, before we add the constraint, when we rotate it, nothing happened with the other component. Okay, so we can add the constraint right now. Mechanical constraint, universal joint. As you can see, we need to select the cross shaft and the hinge point. Okay, here we use this assistant circle as the shaft. The first shaft, and then we choose the hinge point, which is in the middle. And the second shaft and the hinge point. Okay. Now we can click OK to see the result. Okay, we rotate it. You can see the other component will rotate along it. Okay. Okay, the last one I would like to show you is the pulley feature. Okay, we use another case. Okay, as I said before, the pulley command is used for design of pulley parts, like belts, chains, and etc. Okay, now let's see the steps. So first, we call out the pulley command. And then we choose the geometries you need to add pulley to. Okay, for example, here we want to add the pulley for 1, 2, 3, these 3 components. Okay, first we select the cylindrical face, this one, and add it to the list. And the second one, and add it to list. And the last one, add it to list. And also you can change the direction of the belt. For example, you can flap it here, flap, this one, okay. And also you can choose the location datum. For example, we can move it down to this datum, okay. And also you can change the driver length, but normally you do not need to change it. It will calculate automatically, okay. And also you can enable the thickness, like here we make it 2, okay. And then you can decide whether to generate the pulley part for later using. Okay, here we do not want it. Okay, we can click OK to get the result. Okay, this is the pulley feature, and you can find it in the assembly tree. Okay. Just now we have studied how to add common constraints and also mechanical constraints. Next, let's talk about how to edit the constraints for a component. You can find the command in the ribbon or right-click menu. When editing the constraints, you can filter out the certain constraints you want by picking another related component. And also ZW3D allows you to preview and edit the geometry in a small and clean window. And sometimes it may be difficult to find some specific constraints in the constraints folder. Then we can switch between the combine mode and the separate mode. Then we are able to filter out which constraints belong to which component. Okay, now we have built the assembly. Insert the main components and place them properly. But it's not done yet. Normally we still need to insert some standard parts, like bolts, nuts, shafts, and etc. In ZW3D, we can use our built-in library to do this work. The steps are clear. First, you need to find the parts you need. ZW3D provides a rich library like ISO, ANSI, DME, and etc. Then choose the right type, and then insert it in the assembly through different methods. Similar to the way you insert a common component. Besides built-in libraries, ZW3D has been integrated with mainstream third-party libraries, such as TracePart, Misumi, and Part Solutions. For the first two, they are free, and the last one is partly free. To be specific, the popular standards library in the world is charged, which mainly are German standards, which is the DIN, Japan standards, GIS, American standards, ANSI, and internal standards, ISO. Free ones are some special industries libraries, or some famous company libraries, like ABB, and etc. Besides the common way, in fact, we have a smarter way to insert fasteners, which is using the smart fastener command. With it, we can insert the fasteners for different sizes holes intelligently. Okay, now let's move over to ZW3D to show you more details about this part. Alright, just now I have shown you how to add constraints. So next, I'll show you how to edit the constraints. Actually, we have 3 ways to do it. First way is you can add the single constraints in the constraints folder. For example, this one, you can right-click on it, and here you can redefine it, or you can also disable it. Okay, this is the first way. And for the second way, we can use the edit constraints. You can select from a ribbon, or you can just right-click, and then use this one, edit constraint. Okay. And here you can see all the related constraints will be listed here. And you can make a filter like common constraints and mechanical constraints. Okay. And also you can make advanced filter. For example, you can choose another component to filter it. This one. And then you can see it will filter out all the related constraints. Okay. And another tip about the edit constraint is you can show the component in the small window. You can drag it a little bit to make it bigger. Okay. And then actually you can select the geometry in the small window. It's very easy. Okay. For example, here you can select it in the small window. Okay. And the other is similar to the edit constraints. So I will not go further here. Okay. This is the second way. And the last way is using a constraint status. This one. And here actually you can see all the constraint status here. But this is not the point I would like to cover here. So here I would like to recommend to use the pick command. Okay, you can pick two commands. You can pick two components here. For example, this one and the base plate one. Okay, here you can see all the related constraints will be listed here. And also you can jump to edit window. Okay, this is the third way. Okay. And the next skill is about the constraints management. Okay, sometimes it's difficult to find some specific constraint in the constraint folder because you don't know which one belongs to which component. Yeah, it's not clear. So here you can use the right-click menu. Okay, right-click, and here you can see by default it's separated mode, which means the component and the constraint is separated. Okay, we can change it to combined mode. Okay, here you can see this is all the related constraints for the base plate. And this one is all the constraints for the CAM component. So now it's clear, right? Okay. Okay, next I'll show you how to insert standard parts from the built-in library. Okay, the first step is we click on the file browser. Okay, then you can see standard part library. And here you can choose the standard as you like. Here we choose the ISO and the bolts, hexagon head bolts here. Okay, and here you can change it to the big icon. Okay, or you can change it to the list. Okay, here we use the third one. And for these holes, its diameter is 6. And the length will keep it by default. Okay. And actually now you are ready to go. You just click OK. Okay. Now actually you can edit one by one, or actually you can use the auto hole match. We just let the locate the face. Then all the standard parts will be inserted. Okay, we click OK to get the result. Okay, so this is the basic workflow to insert the standard parts. Okay, and beside the built-in library, as I mentioned before, we have some third-party libraries. You can find it in the app. Okay, in this tab you can see we have trace parts, Misumi, and part solutions. For the trace part and the Misumi, this is all for free. You can download it and just use it freely. Okay, but for part solutions, it's partly free. We can open it. If you first open it, you may need to download the install package and install it. Okay, so here you can see there are two categories for the part solutions. The first one is national standards like ANSI, DIN, GB, ISO, KS, and etc. And in the below area is all the industrial standards. Okay, so for the national standards, it's charged, so you need to buy an extra license. But for the industrial standards, it's all for free. You can use it anytime. Okay. Besides that, we have a smarter way to insert the standard parts. Okay, we use another case, this one. So for this one, actually you can see we have different sizes of holes. You can see big holes and a small hole. Okay, but here we can use the smart fastener command. Okay, Okay, all we need to do is select the locate face. Okay, we select this one. And here you can see actually it will calculate the holes and match the standard parts intelligently. Okay, so here you can see we have two sizes of standard parts. First one is the size is 2, and the second one is 3.2. Okay, and if you want to edit it, you can just double click it. Here you can see double click. Now you can edit. For example, you can edit the diameter, the length, and other parameters. Okay, and also you can add top stack or bottom stack. Here I'll show you how to add the stack. So take the top stack as an example. You can check it, and here you can see we have add a top stack here. Okay, and for the other one, which is size 2, we also can double click it and add top stack. Okay, now you can see the difference. Okay, this is a very smart way. Okay, and after you click OK, you can see all the smart fasteners will be in the smart fastener folder. Okay, so this is another faster way to add the standard parts. Okay,